Okay, look at question 58. Show that the line, you are given the two lines. Okay, I write here, I copy it here. Okay, but I copy in this form. So 1, negative 1, 0 plus lambda. And then this one is 0, 1, 1. J is 1, K is 1. Okay, I call this one to be line L1. And then the other one, the R, X, Y, Z is this one, 0, 1, negative 1. This is 1, 0, negative 1, okay, mu, okay. So we have two lines. So we are going to show that these two lines where lambda and mu are parameter have no common point. That means I'm going to show that they do not intersect. There is no point of intersection. So you see, for these two lines, if they are not parallel, doesn't mean that they will intersect. Okay, but in form 4, yes, because form 4 we do two-dimensional. Okay, in form 4 we do two-dimensional. If the two line doesn't not parallel, then they must intersect at the point here. But now our problem, we are dealing with three-dimensional. That means maybe one line is up here. Okay, they pass through at the top here. So even though they are not parallel, but still they do not intersect. Okay, so from here you can see that to show that the two lines have no common point, that means we are going to show that the two lines do not intersect. So to note, the two lines not intersect can be parallel or non-parallel for two-dimensional cases. So that means they can be parallel like that, so they don't intersect, or they are not parallel but one is on top of the others. So they don't not like that. That one is on top of the other, so they don't intersect also, even though they are not parallel. So parallel, of course, they cannot intersect, but not parallel, one is on top of the others, they cannot okay, they cannot intersect. Just like you see in our star, all the road junction, we have two road like that, because you see all the road junction we must have a traffic light, because why? The road intersect. But in KL, the crossroad, they will build a flyover, isn't it? So you see, they don't need to use the what we call traffic light, because the road will not intersect, even though they are not parallel in the same direction. They cross each other, but one is on top, one is at the bottom, so they don't intersect. There is no common point, isn't it? That's why they don't need to build the traffic light. Okay, to find the point of intersection, we solve the two equations simultaneously. So we solve it simultaneously. So the first one, L1 is this one. The second one is L2 is this one. So X, Y, Z, same. This is the common point where they intersect. The X, Y, Z is the common point, is the point where they intersect. So you solve the simultaneous equation, you equate them, then you get this. After that, you just find this. So mu equal to 1, so this one equal to this one, you get lambda equal to 2. Then when you substitute here, you see they must consistent. So when I substitute lambda 2 equal here, and I substitute mu 1 here, I get 2 and negative 1, they are not equal. So if they are not equal, that means you cannot find a common point. There is no common point. Okay, I mean the value for mu and lambda that we found here should satisfy all the three cases here. Then only they intersect. Okay, so the two lines do not intersect, so they have no common point. That's how you show they do not intersect, because the mu and the lambda are not consistent here. They are okay. The mu here, mu is 1, lambda is 2, but here they not satisfied. That means we say that not consistent. Okay, so we say that mu and lambda, the values of mu and lambda are not consistent. That's why they don't intersect. They have no common point. Just like they are just like the flyover. One is on top of the other, so they won't meet. Okay.